All right, so number 9. Which of the following is expression of the function f that's Maclaurin series of 1 plus x squared over 2 plus x squared or 4 factorial plus x to 6 over 6 factorial, blah, 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 blah.
So this is just cosine? Alternating.
Now, if it was cosine, it would be what? It'd be alternating. Since it's not alternating, we know it's not cosine. All right. Now, we do probably want to write the ones you know. All right. Which ones do we know? All right. We have e of x, which is what? X squared over 2, 2 factorial plus x cubed over 3 factorial. All right. Okay. What is sine x? Sine x is alternating. Alternating odd, which means that is what? So x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. Now, if this was b, again, if anything, we have multiple choice. It is multiple choice in the test. Right? If anything you have multiple choice, you can figure out which one it can't be. Right? If it was b, that means I would subtract these two, right? So I would have, if I subtract these two, that will be gone, right? Which it is. I have 1, all right, plus x squared over 2 factorial. But if I subtract a what? A negative x cubed over 3 factorial to have a plus x cubed over 3 factorial. Do I have that?
If you have 1 minus negative 1.
Oh, that would be gone. That'd be plus 2, right? Plus 2, yeah. Yeah, so that, it can't be b either. All right. Well, let's see here. So we know it's not going to involve sine x. Now, what's the next easiest one to do? Yeah, D. The next easiest one is to do is D. All right. Yeah, just do cross elimination.
Yeah.
Yeah, only thing it does is it replaces every x with what? X squared. Okay, so I'd have 1 plus x squared plus x to the 4th over 2 factorial, right? And that's not there either. So it has to be what? C. It's multiple choice.
If we show that like all the other ones can't be, we could.
Then that's perfectly fine. Now on the test, it might actually be easier to show the one that does work. Okay.
See, but there's a bunch of random stuff on there. Notice
Not that bad, but this again is one of the more challenging ones. But yeah, if we did this, all right, if I have a negative e dx, what would I have there?
you have negative x.
I would have a negative x for every what exponent? Odd exponent. So what would happen to every odd value? It would subtract. Now I would add every even value. So it would pretty much double every even value, and it would subtract every odd value. How do I get rid of the doubling though? The 1/2. So yeah, you could show that C works, or you could show that the rest of them don't. Okay. All right. Yeah, you would add those two. Yeah. All right. Find the Maclaurin series for the function. Yeah, you have a question, I think, like this, except it's just a different function. Okay. Maclaurin series is not hard to do, right? Now, for the first 4 terms, which means we do need to find f prime of x, right? Which is.
F of x is sine.
All right.
Write out sine x and then. There's a professor of that. No question. And the cube that I have words. Then F5 would be 6 x squared sine or cosine x cubed. Sine x equals x plus. And then don't we do it? So it's a 4 Maclaurin.
It's the 4, so we need x double prime, x triple prime, and fourth.
And then double prime would be.
That would be. Wouldn't that be product rule?
Negative 7 x cubed sine.
No, wait. We're doing this all wrong. Sorry, I didn't think about it. Yeah. All wrong. What do we have to start with? What are the first 4 terms of sine x?
X minus x to the third over 3 factorial plus 5 to the fifth. I mean, x to the fifth over 5 factorial.
So the first 4 non-zero terms. You're going to go out to 4 terms. So that means x to the 7th, right? 5 factorial minus x to the 7th over 7 factorial. And then what do we do? We replace every x with x cubed. All right. So sine of x cubed would be x cubed minus x to the 9th over 3 factorial plus x to the 15th 5 factorial minus x to the 21st over 7 factorial. And then what do we do? Yeah, multiply everything by 2. So 2, 2, 2, 2, 2.
Could you put the 2 to the 9th and then the 2 to the 15 and the 2 to the 25? Because that's what they did in the
No.
X to the first one, x to the 4 because it's. What did you just say?
You can simplify this a little further if you want, but I'm not made a reason to.
On the homework they managed to they
If the 2 is inside the parentheses, yes, but the 2 is not inside the parentheses.
post 2x.
Yeah.
Then we would okay.
So yeah, that's it.
Oh, maybe. What's the first one? Sine x. 2x to the 4 because it's x times x cubed.
Now you're replacing x with x cubed. So x to the cube to the 1 power is what it is. You multiply the exponents. That's what we did for each of them. We just multiply the exponents. Since it's a 1, 1 times 3 is 3. Good question, though. It would. Just a lot of things would cancel out because we'd have to plug in 0 in for cosine and sine each time. So the cosine and sine values would go away. It would just simplify to that, and it would be so much more work to simplify to that. So, yeah.
So you need to the cosines on
In E, you don't have to know 1 over x for this test, 1 over 1 plus x for the test, but you do need to know sine, cosine, and E. Squared. Yeah. Yeah, that's the one you don't have to know for this test. Huh? Yeah. All right, so Maclaurin's theory for the function 1 over 1 plus x, okay, is defined by this, which is what we just talked about. It's that 1 plus x squared plus x cubed plus all that fun stuff. So use the fact that the first 4 non-zero terms and the general term of the power series expansion for this. So what is the Maclaurin series for this? For the first 4 terms? 1 plus x squared plus x cubed. All right. Then we have 1 over 1 plus x squared. What would I write that? This is 1 over 1 plus x.
1 minus
I don't think it is okay, you're right. All right. So what's going to happen when I replace x with x squared?
Also, just be all positive.
Nope, because you're just replacing the x squared, every x with x squared. We also want the general term, and we know the general term for this was that -1 to the n, x to the n. This is -1 to the n, x to the 2n, right? And then what's going to happen to the x squared? Yeah, every term gets multiplied by x squared. No. Yeah. So this becomes x squared minus x to the 4th plus x to the 6th minus x to the 8th. So basically, what did I do to every exponent? Yeah, added 2 to every exponent. I mean, the first one gets multiplied by x squared, but that's fine. So -1 to the n, x to the 2n plus 2. There it is. Sit on your test, you guys see? Sit. Yes, you'll need to know this. This is a question on your test. No, you don't have to find the general term on the test. All right, there was another question that was asked while I was talking.
Why are you adding them on that one and not multiply?
If I took this times x squared, what do you do to the exponents if they have the same base? If I multiplied this one by x squared, like what I basically did to get this next value, what happens to your exponents? Do you get when you have the same base? You add the exponents when you have the same base. So if I had x to the 3rd times x to the 4th, that gives me x to the 7th, right?
Yeah, so when do you multiply them?
So when I multiply these with the same base, I add the exponents.
So where do you multiply it?
When it's something like x to the 3rd into the 4th. So that's what we did here, is when I replace this with x squared to the n, that gives me x to the 2n.
I just kind of watch it. It's equal of x squared. It's just 5x. This is 2x.
You just know the rule and be done with it. You don't have to read anything.
Or if I didn't never remember the rule.
Hey, not rules, they're rules. This isn't English. These are actual rules that mean something.
Never remember anything.
All right. Number 12. Let t of x equal 7 minus 3x minus 3 plus 5x minus 3. So we know this is centered around 3. For the 4th degree Taylor polynomial for the function f, x about 3. Find the 3rd degree Taylor polynomial for the derivative f prime. Okay, so what do they want us to do? Yeah, just take the derivative and then plug in what? 3.3, yes. So what is t prime of x first? What's the derivative of 7? 0. Now, if you distribute this through, that's going to be negative 3x, right? Plus 9. What is the derivative of negative 3x plus 9? Negative 3. So that's done. Now, for this, we'll just do chain rule. All right, so bring down the 2, it gives you 10. Derivative of what's inside is just 1. All right. 10x minus 3. Because you do chain rule.
Yeah.
So same thing, chain rule, bring down the 3, so minus 6, subtract the exponent. Bring down the 4, 24, subtract the exponent. And the reason why we don't worry too much about the chain is because what's the derivative of what's inside? 1. All right? Then we basically find t prime of 3.3, which gives me negative 3 plus 10 times 0.3 minus 6 times 0.3 squared plus 24 times 0.3 cubed. And you can just plug that in the calculator. What does that give you? Negative 3 plus 3. Basically, that first would just cancel out, wouldn't it? So that's gone. It's nice to clear that. So negative 6 times 0.3 squared plus 24 times 0.3 to the fourth. No, to the third. 0.108. And that is the answer. All right, so let me refresh questions on the review you're going to have. You're going to have question 1, 2, 3, 5, 6. Yeah, not exactly same, but same concept. So question 1, 2, what was that? 3, no. Yeah, question 1, 2, 5, 6, 7, 8, 9, 7, 8, 9, 11. Where's 10 at? What is 10?
I'm going to do the function that I think two sides do.
Where's that? Why is it 11?
Maybe
Okay, because 10 and 11.
Actually, 10 and 11 are very similar, aren't they? So yeah, 10 and 11. They're kind of the same question. Okay?
Yeah, Mars.
Alright. See here. Also,
Monday.
no, tomorrow. Oh, response Monday, yes. Also, homework 10, 11. The stuff about Taylor and McLaurin series. Let's look at those. That assignment. So let me exit out of here. So,
Are there going to be any from 10%?
no.
10 to 11.
Alright, number 3.
Why or how will you use the ratio test
Hmm?
on it on the test?
How we use ratio tests?
No, like what concept will we? Or like give an example of that one that use the ratio test, like will be what number?
Finding interval of convergence. Remember, you need the ratio test for that.
What number is this?
But yeah, anytime it says find interval convergence, you're using the ratio test. But that's the only the test you need to know, because you're going to use that to find interval convergence.
So in both versions, n plus 1
Over.
And what?
Or times by this. Yeah.
What will the?
Alright.
Thank you.
So not only number 3, so not only this question, but also number 9.
Those are the proof columns.
No. No, these questions will be the multiple choice.
Plus the
I will get to that in just a second.
so
So that covers, one more question. 10-15. 10-15, number 2. So, study those questions.
Oh,
Yeah, that's it for the multiple choice. Any questions about those? All right. Now, for the free response, go back to 10, 11. Yep. Now, this was funny because you guys actually asked me about this one. Number 16. What kind of function is this? Differential equation. There you go. So, in order to do the Taylor polynomial for second degree, which just means we have how many terms? 3. So we have f of, now this is centered around 0, so f is 0, plus f prime of 0 times x, plus f double prime of 0, x squared over 2, right? Now, nice thing enough, this gives me f of 0. F of 0 is what? 6. How would you find f prime is 0? You have f prime of x. That is f prime of x. So what is f prime of 0? Plug in x and y. Now this doesn't have an x, so you don't have to plug in 0 anywhere. Just plug in 6. 1 times 4 minus 6 gives me negative 2. So this becomes minus 2 times x. Now, how do you find f double prime of x? Take the derivative of this. Now, because we have, it might be easier to actually distribute that through. Write this as 4y over 6, or you can write it as 2/3. So 2/3 y minus 1/6 y prime, or y squared, and then take the derivative of this. Now, when you take the derivative with y with respect to x, what happens? Yeah, you put in y prime. So we have 2 over 3 y prime minus, let's bring down the 2, you get actually 1/3 y times y prime. Now, the nice thing is, do we know what y prime is? It's negative 2. This is y prime as well. So, replace y with what? Replace y prime with negative 2. What do we replace y with? 6. So 2/3 times negative 2 minus 1/3 times 6 times negative 2 gives me negative 4/3. Plus, that's going to give you 12 over 3, 4, which is something. I don't know. What is it? Multiplied by 3. 8/3. So plus 8/3 x squared. Which, if you check your answer key, I think that's the answer. Pretty sure. Let me check. Oh, you're correct. Very good. You caught my mistake here. I forgot to put this over 2, which means what do I do with the 8? Yes.
Correct.
Yeah, I can just put it right there. Thank you. I make the department cookies all the time.
Wow.
Oh, I said I make the department cookies all the time. So it gives me 4/3. That'll give me 4/3, which, let me check, that is number...
Yeah. Well, I thought it 8/6 simplifies something.
Is it number 16? No, where's reducer fractions? But that is correct. That is the answer for that question. Now, if you were tasked to find a specific value, what will we do to... Yeah, you plug in the value. So for part B, plug in 1 and for x and solve. All right, now here's the difference between this and the test. You are going to be given a slope field. Slope field for difference equations, remember chapter 7? We started this semester with chapter 7? Yeah.
You give an example, maybe?
Like that one where it was just like a bunch of lines all over the graph.
Yeah.
And how are we supposed to find it?
You're not. Not asking you to do that.
Okay. Are you?
What first part A of that question is going to be use the given value, the given point. Okay, in fact, if this we had slope field for this one, it's a use 0.6 to sketch the graph of the curve. So you're given a slope field, you're going to sketch the graph of the curve that goes through that point. So let's see
And because
if I can find something like that.
at a point, and then she plug y,
Oh, so it'll already be on there?
Yeah.
Okay.
like coloring lines.
Kind of, yeah.
Is it gonna be one of the ones where we have to create the slope field or we have to draw the line on?
So basically, you're going to be given something where scroll here. Yeah, scroll right. Say you're given this slope field, and I give you the coordinate 1, 1. Well, let me do this in red so we can see it. So 1, 1. I want you to sketch the graph based on that. So you would again use the curve, make it a bit bigger. Is it bigger? Better. All right, so you would show that it would go along these lines. It doesn't have to be perfect, but it should be pretty accurate. Okay, it's not going to be hard to do it all. And I know it's me saying that, but it really isn't. Okay. So that's part A. It's 1/4 of the question. The second part is if I give you, say, let's go back to that question we had just a second ago, and I say, what is the tangent line? What is the function or the equation for the tangent line?
Isn't it just the slope at a point?
Mm-hmm. 0.6, the given value, 0.6. And did we already do that? So y equals -2x to your function.
But I thought you said you weren't gonna give it a function.
No, you have this. You have to have this. When did I say that?
Because I said what would we be graphing and looking?
Well, no, he's saying that we aren't gonna use that function, we're gonna use lines.
That function is used. Yeah, that function is used to create the slope fields.
They won't give us a function.
Yeah, they won't give you the original function. I mean, you could. I mean, I'm not going to ask you to create the function either. That's the function for the slope fields. So, and since x is 0, it'd just be x minus 0 and then plus 6. You could write it like that, or you could write it. You can simplify it. I don't care if you simplify it. Okay, I don't care if you keep it in slope-intercept form. Okay, or point slope form. Keep it in point slope form. It's perfectly fine to keep things in point slope form. All right. Other than that, let's see here. Oh, we're on this one. Yeah, here we go. So, hold on. Ah. If I can find the question, I thought I did find the question. Let's go back here. To Lagrange error bounds.
So this is the next part here.
No, this is the last part of this. Yep. So, now, the Lagrange error bound is going to ask you to take your approximation, so like part B of that last question, and then show that the next, since it goes to 2, what's my next? The third interval, the third value, or the third estimation, the third term, basically. Use Lagrange error bound to show that the approximation from the previous answer differs from the actual value by less than this. Okay, so basically this question right here. Okay. So yeah. This is 10.12, number 9. Part B specifically. Now, this question again, it's not hard because what do they give you? They give you the max value, so you just plug that in. They give you the value they want you to plug in for x, so you plug that in, raise it to that. So if I had to do that for that previous equation, since we went to how many decimal places? 2, we would go to f. On your test, it would give you an interval for f3. Say f3 was less than 0, less in this case 48. Let's just say that's what we were given. Okay, so what's your max value for the 48? So we have 48 times, in this case 1.5, 1.5 to the third power over what? 3 factorial. That's all you do. And you simplify it, and you show that that value is less than my previous answer. Okay. In this case, it would be for that. I'm just saying for my previous question, I only went to two terms. All right, for this question, you would do 4, yeah. No, you not on the test. The test is only going to go to 2, so you do 3.
Question.
On this question, yeah, you go to the fourth term. Fourth. Yes, in is 4. So yeah, it should have been 48 times 1.5 to the fourth power over 4 factorial. Okay. Yeah. All right, so that's part A, B, C, D. All right. Now, most of the points are going to come from part C because that's creating the polynomial and the estimate. A couple points for part A, a couple points for part B. Again, part A and B is A is just graph it. Part B is find the tangent line. Those are very easy to do. In fact, you're going to use your answer in part B in your part C because you need f prime of 0 or you need f prime of 2, whatever they give you. All right. So I just didn't want this to trip you up because this is pretty easy if you just know what to do. All right, that's the first. That's the first one. The second one. Well, the first or second depends on which one you start with. So this one is all about your Taylor series. Okay. Now it is your Maclaurin. It will be Maclaurin because it will be centered around 0 because we love that. All right, let's see if I can find. Let's go back to Taylor and Maclaurin and see if I can find a good question. So.
Are there full questions?
Yes. Mhm. Mhm. Let's go to.
Are there questions for this one too? Can we have?
I guess. See if I can find one. Let's look at this question. The function f defined by fx is this, right? What are the first four non-zero terms? Just find the first four non-zero terms here. This is the last one, 10, 15, number 2.
Well, we already have one for, that's for the multiple choice.
Yep. So what are the first four non-zero terms?
It's the,
So yeah, x squared.
Like this is a part A.
I'm going to build to something here.
A just be like listing for four non-zero terms.
yes.
Non-zero terms is the like the final.
Just 1 second.
Yes,
Ask this question.
Is that in the organic?
On Maclaurin series, where is that found? F4 of 0. So it should be f4 of 0, all right, times x to the 8th over 4 factorial. Okay. Yeah. So in this case, yeah, it would equal 1. Dang, that's not good. Let's try this then. Let's make it simple.
You like explain what you're doing, like
So I'm trying to find a question like this. Problem is, I don't have one. Yeah.
With something like this, except it ended up being like 2x to the 4 over nothing, and that was when you had to do
Yeah.
times 4 factorial, like 2 times.
Was it in the notes? It was somewhere. I mean, I know I've seen this question. I just can't find it right now. So let's leave it as just x to the 2n. All right. So that's say what we had. All right. Now, how would I find f4 factorial? F4 of 0. And let's even do this times.
so is this getting into a second part? Like or is this part A? Like what is
Let's try that. What is f4 0? Yeah.
We need to like solve out all 4.
Which means here's the thing. f of 0 would just be,
No.
This is 10 fifths. Oh.
it's my initial value, right? What's my initial value here?
F of 0,
Yeah.
it would be x is equal to x squared. Are we plugging 0 in for x?
That's a good question. All right. In this case, your f of 0, you're plugging in not plugging in 0 for x. You're just finding your initial term. All right. So what's your first term? What would you get if you plugged in 1 in for n? So 3/5 x squared, right? F prime. What's your derivative of this? Now, when you take the derivative, does the 3n to the 5n do anything? No. So that is basically 3n, 5n. All right. Well, in this case, n is what? Oh, n is 1. That's right. In last case, n would actually be what?
How do you go from F of 0 to F prime of x?
Well, I wanted you to take the derivative of x to see what happens.
X?
So what's the derivative of x? 2n to the x to the what? You take the derivative, right? 2n minus 1. All right. What is f double prime of x? 3 over n, 5n, right? Times what? 2n times 2n minus 1, x to the 2n minus 2, right? It's the next one. You keep going, right? So 2n times 2n minus 1 times 2n minus 2. Does this look any familiar to you? There it is. So basically, I'm going to have this. Every time I do a derivative, okay, f to the n of x will be 3 to the n over 5 times n times 2n factorial x to the what?
X and minus. Yeah.
It'll be
X is equal to 2 and minus 1.
it would be 2. Yeah. No, it's not 2n factorial. It'll just be 2n minus.
X. It's minus n minus 1, isn't it?
Minus, because we're decreasing. We decreased by 1, decreased by 2, so we're actually decreasing by n in this case, aren't we?
Right.
So that would just be x to the what? If I do 2n minus n, that would just be x to the n. But I can leave it like that for now. It's fine.
Part A.
Okay. Yes, it's part pi.
This is English terms.
Okay.
You said this out loud. You said, what is f of n of x? Like that is, when we take the derivative of what? Like what does that mean?
I mean,
F n of x. What does that mean?
x, f to the n of x, that is the nth derivative of x. Yes.
Is it, okay, I know it's going to do the n over 5, is it 5 times n or
5 times n. 5 times. Yeah.
statement that are you saying like every time we take the derivative of x, it'll be 3n over 5n cubed n factorial x cubed n minus n? Is that what you're saying? Is that the same?
Yeah.
Okay, so you might trying to figure out. If you
With that in mind, can you find after the 4 of 0?
Yeah. Is that if you use n for the derivative and you're using n from the original.
Yeah, no. It might be easier to use like k for the. Okay.
that's for my computer.
Can you correct the problem real quick so you can
Right. After that, be able to use a Taylor series. I'm sorry, use a ratio test to find the interval convergence for something like this. So take that right there. Use the ratio test to find interval convergence. Find the second degree Taylor polynomial for that. Find the second degree Taylor polynomial for that. All right. What I wrote up here. It's similar to what's on the test. All right. And lastly, you honestly don't need to worry about. The fun part about the part D is you don't need anything in the previous 3 parts. All right.
you can get it right.
Yeah. It's another Lagrange error bound question. So you can get it without using anything from the previous questions. You only need the data that you give you. All right, that's your test. By the way, what is f of 4? It would just be this right here, right? Where n is 4. So 3 to the 4 over 5 times 4, 8 factorial. But what are we dividing by at f of 4? 4 factorial.
Can I turn in
Okay.
can I turn in the homework tomorrow? I can tell you them tonight.
Yeah.
Okay.
Actually, would you need? No, you wouldn't need to do that 4 factorial because they only ask you for f of 0. Now, the nice thing is you don't need part A to answer part B and C. Okay.
Is there any way I can discuss like
You have not been here since when? Yeah, you're not taking it tomorrow. You can take it next week. It's fine.
Okay. I'll probably do Thursday before the long week.
Both parts
Yeah.
on Thursday. Okay.
Or both parts on Thursday, that works too. If I don't finish it Thursday, I don't have a 6th or 7th hour, so.
That's fine.
just do that.
6th hour is just A/B calc. 7th hour, I don't have a class. Okay.
Okay, thank you.
No problem. Okay.
Heather Hubbardly, Kirsten Pepper, Mark Thomas, Lillian Worrell, Simpson, Audrey Johnson, Clara Wright, Aaron Peninsky, Pascal Fowler, Alexis Hunter, Dorian Caputo, Ryland Trotter, Lucian Rudder, Reed Earhart. Student at please.
Let's see here.